In today's video, we're going to be looking at the plug. The plug is the part of most electrical appliances that lets them connect to the mains electricity. In the UK, the domestic electricity supply, which is the electricity that goes to your home, has a potential difference of 230 volts and a frequency of 50 Hz. Our mains electricity is an AC supply and we have an alternating potential difference. Well, what does that mean? Well, in an alternating current, the potential difference rapidly moves between the positive and negative as the current alternates in direction. This is the opposite to a direct current, where the potential difference has a consistent voltage and would look like this, a horizontal line. This is the type of current that's produced from batteries. You use these plugs almost every day to plug something in, but how often do you think about what's going on inside? So let's open it up to have a look. Well, the plug is what connects your device to the mains electricity, and it does so using this 3-core cable. Now, as you can see, this plug has been put together and taken apart quite a few times. It's starting to fall apart a little bit. And we call this cable here a 3-core cable. And the reason why? Is because it's got 3 wires inside it. Now you can see that you can tell the difference between the wires because they've got different coloured insulation on. This makes it easy to identify which one is which. First up, we've got this brown wire, which is the live wire. The live wire carries a 230 volt potential difference from the power supply to your electrical appliance. Next, we've got the blue wire, which is the neutral wire. This completes the circuit and has a potential difference of around about 0 volts. This is like the exit, taking the current back to the mains. And then we have our third wire, which is this green and yellow wire. This is our earth wire. And this is a safety wire. The earth wire is connected to the case of your appliance, so if something goes wrong with that, it provides a low resistance pathway for the electricity to pass through, rather than flowing through your body. The earth wire is at 0 volts and will only carry a potential difference if there's a fault. Well, let's go back to the plug. So what about this thing here? This is a fuse, which is a built-in fail-safe device. Inside the fuse is a thin wire. If the current gets too high, then the fuse will melt. This will cause a break in the circuit and stop the current flowing. So let's get rid of this. We can use this demo to see how our plug works. So our plug's connected to our main supply over here, and here we can see our plug with our neutral, earth and live wire. Now they're going over to our kettle here. So when we turn this on, we can see the red LEDs indicating that we're going to be heating our water up. Our kettle's working absolutely fine. The current is flowing through the live wire, back through the neutral wire. Our circuit's complete. We're going to remove our earth wire for the moment. And we're going to imagine that this live wire has come loose and started to make contact with the kettle. Now our person here, unfortunately, is touching the kettle. So when we turn this back on, the current is flowing through the person. And this is because they're at a much lower potential difference than the live kettle. Obviously, this would cause an issue. Again, we're going to turn that off. And we're now going to put the earth wire back into place. We're going to see what happens. But this time I want you to have a look over here at our fuse. So now our earth wire is back in place. What's going to happen when we turn our current on? There we go. The fuse has blown, stopping the current, and it doesn't flow through the person, saving them from touching the device when it's live and going wrong. So there you can see just how important that fuse is in protecting you and keeping you safe when using electrical devices.